Hey, this is for engineering design or rocketry class. It's really a test to see if we are able to use the Educanon system correctly and also to inform you of sort of a new thing that I've added this year to rocketry, and that's going to be a presentation that your team's going to have to do. Okay? Let's talk about the engineering design process. For some of you, this may be new, but for most of you have heard about this in robotics. So what is the engineering design process? Simply put, it's kind of an engineer's version of the scientific method. It's a systematic way of designing a product in order to answer a design product problem or question. So in this case, we talked in class what our design problem was and the constraints that the rocket needs to follow. And now this gives you a systematic way to design that product to successfully um, achieve those objectives. First thing you need to do is to define the problem. I think we've already done that, okay? Next thing, do some background research, okay? This can be done, as I mentioned, there are lots of videos on apogee rockets. We will talk about aerodynamics and rocket flight in class probably next time. You need to do some research so that you can become informed on just what are the factors that affect the flight of a rocket and some principles of rocket design. The next thing you need to do is also specify what the requirements of your individual rocket are, okay? Are there some weight requirements that you feel are important? Are there other requirements such as engine size? You need to talk about this as a group. Create alternative solutions. We talked about this. You're going to design more than one rocket for alternative conditions, and also there's more than one way to achieve the objective. So I would like you individually to design the rocket so that we at least come to the table with at least 5 different designs. Choose the best solution, okay? There may be more than one best solution. This will be determined through our simulations and through our actual testing of the rockets. Do development work. Okay, so once you choose the best solution, you need to actually build the rocket. Okay, if you've just tested it on RockSim, that's not going to be real world. Hopefully, it'll be close to real world. And we talked about how you can adjust RockSim for real world conditions in class yesterday. Build a prototype, just like we do in robotics. And what do you think the last step is? Maybe we need to test the prototype and redesign or modify, okay? So for all engineering, this is basically the series of steps that engineers go through. They refer to it as the engineering design process. Like I said, it's very similar to scientific method, except it's kind of been tweaked for designing products. Your presentation. Okay, your team will create a PowerPoint presentation, or it could be a video presentation. I don't really care. It should include at least the following. Okay, I've left this blank because you guys are going to determine what it needs to include, okay? And we'll do that in class, what you think should be in that presentation. It'll be worth 200 points. When it will be due, 1 week after completion of our third flight. So whenever we complete our third flight, 1 week after that, you'll be making the presentation. I would caution you that this is not something that you can just do in the last week. You need to be collecting data because you need to have pictures, okay? You need to have data from all your flights that led up to your best design. So you can't just say, well, I'm going to do this in the last week, okay? We'll talk more about this project as it goes along, but I just wanted, one, to test out your Educanon and make sure that everybody is logged into Edmodo, and we'll go from there, okay?